Good afternoon, everybody, and welcome again to becomeatechpro.com. In today's session, we want to move into shell scripting. Okay? Shell scripting. So let's look at the two words, okay, that make up shell scripting. The first one is shell, and the other one is scripting. Okay? So when you say shell, what does it mean? Okay, so shell is an interface between the user and the operating system. Remember, we talked about operating system when we're introducing ourselves to Linux. We talked about different distributions of Linux, right? We've seen other operating systems like Windows and Mac OS, right? So when you say shell, okay, in Linux, it is the interface between the user and the operating system. Okay, so we can look at it as that program that takes the command from the user, right, and gives it to the operating system for execution, right? Because we've been running commands mkdir, uh, touch, echo, all of those commands that we've been running is only possible because of the shell. Okay, so shell is the interface between the user and the operating system. Okay, so let's just okay, file. Okay, so shell scripting. Let's add a new file. Let's call this shell scripting. Okay, so shell scripting. Okay, so we've seen what a shell is, right? We've seen it as the interface that collects command from the user and gives it to the operating system for execution. So that is a shell. Okay. So now the scripting part, what is it about? Okay. If you if you've seen movies, right, you see several movies and the actors and actresses in those movies, they are given scripts to work with, right? And if you look at the script, it follows a certain pattern, right? Like, oh, this actor says this and expresses this emotion, and the next actor or actress says that and expresses that emotion, right? It follows a particular order, right? For the film to be made, right? For the acting to be done, okay? So also with shell scripting, right? There is usually a certain order, right? So when you say shell scripting, okay, it is the collection of several commands, one or more commands actually, because it could just be a single command, right? But when you document command or commands in a written format such that you give it to the operating system for execution, you have shell scripting, okay? For example, we've been running commands, touch, right? You say touch a file, let's say file name, right? Right? You do this, you touch a file, right? Then you go ahead, you mkdir, right? Mkdir, maybe a directory, our directory, let's say that's directory name, right? So these are commands, right? But when you put those commands in a file, you see, this is my file, right? This is just a simple YAML file, right? When you start to put all this in a particular file, you have shell scripting, okay? So in this case, you want it to create this file, you want it to create this directory, right? After creating the file and directory, you say move the directory, right? Something like this, mv file name.txt. You want it moved into our directory. You see, there's an order, right? Create a file, create a directory. Now move the file into the directory. But if you decide to do this, cut this, and paste this under, do you think it makes sense? It doesn't, because you are moving a file into a directory that does not even exist. And you see, you are going to get an error at this point. Like the file name does not exist, the directory does not exist, right? But if you just do the simple thing and make it follow the certain order, right? Then you can talk about having a shell script, right? That is going to work because the order makes sense, okay? So now that is shell scripting for you. Shell scripting, right? We are looking at shell plus scripting, okay? So we've defined shell, okay? We've defined shell as the interface between the user and the operating system, right? That is a shell, okay? So it is that program that takes commands from the user and gives it to the operating system for execution. Okay, now that we know what a shell is, okay, so what are the types of shell? Okay, so to ensure that this is not so theoretical, okay, to ensure that this is not theoretical, let's try to open our Linux server and try to see all of this at work, okay? Let's open our Linux server and try to see all of this at work. So back to our Linux server. Let's log out of here. Okay. February 2023. Okay, so we'll continue to use the server we had all along since this is shell scripting. Okay, so instances. So you can just come here, instance state, and start the instance. Okay, so while this is opening, let's see what we can do. Okay, so but before then, we can quickly take a look at the different types of shell that are available. Okay, different types of shell that are available. say bash, okay, okay, there's bash, okay. This bash, okay, the full meaning is born again shell, okay. So this is usually the default version that you find in newer versions of Linux, okay? Born again shell, okay? Whereas there's another one called SH, okay? This one is the born shell, okay? Born shell. So this is born shell, okay? This version is usually the default shell that you find in older version, okay? Born shell, okay? This born is, let me see, born. Let's take a look at some history around born. Born, okay? Born, that's born again shell, born shell. Let's look at some history around born, okay? You can see born shell, okay, is a command line interpreter. You see, let's take a look. I want to look at the full name of the person that introduced born, okay? Born. So the name is Born. Just trying to find the full name. Stephen Born, okay? So Stephen Born used to work at Bell Labs, okay? Stephen Born used to work at Bell Labs, okay? And SH, right, was released in 1979 in the version 7 Unix release, okay? You can see, so this is the name I was trying to get, Stephen Born, okay? It was one that this Born shell was named after, right? You can see, /bin/sh, okay? So now, the bash, born again shell, was an improvement over the sh, okay? So apart from this, there are other types of shell, okay? There are other types of shell. There's the C shell, CSH, which stands for C shell. There's the TC, TCSH, right? Which stands for tiny shell, right? There's also the Z shell, okay? Z shell, ZSH, okay? Z shell, right? And there's also the KSH, right? KSH, right? Which is the default that you find in AIX, right? Which is IBM, right? So that's the default shell in AIX, okay? Default for AIX, okay? AIX. So this one is default for newer versions, and this is the default for older version. But our emphasis is going to be around bash and sh, okay? Bash and sh, that's born shell and born again shell, okay? So bash and sh will be where our attention will be. Okay, now if you remember, So far, we've been working on this server, right? This server, let's refresh it. It should be up now. So far, we've been working on this server, right? So we can just go ahead, copy this, right? Can copy this and just come here. Let's use this today. I'll use a git bash. Let's clear. Okay. So using our git bash, we want to connect to the server. So just copy that, right? Remember in the last session, we analyzed this, so we understand how it works. But I can just, if I try running this right here, right, it won't work because this is not where my key is, right? See, it says no file or directory, right? So you see, it won't work because there's no file or directory there. So it's asking me for a password. So I want to kill the process, Control C. So the first thing I want to do is to go to downloads. That's where file my file is. Okay, so you see ls.pem, ls wildcard, anything that ends in .pem, you see. I have two keys here, okay? So if I run the command again, you see, it will connect me. See, I'm in. So uname, you see, it will tell me it's Linux, right? You can see. So I can clear this now. And since I'm now in my Linux server, right? I'm now in my Linux server. I can try to see, okay? For you to know the types of shell you have, okay? There's a file in the /etc directory, okay? Called the shells file, okay? Remember, okay, I know where to go. I can just cut the file, okay? But I don't want us to load too much, have too much in our head. So there's a file in the configuration, in the directory containing configuration files, okay? There's a file in there called /shells, okay? So if we go to, if we say cat /etc shells, it will tell us the shells that we have. You can see, tells us the shells that we have. So all the shells that we have are listed here. You can see we have the born shell and we have the born again shell. Okay, there are other shells that we do not have right here, right? There are other shells that we do not have in here, okay? So, for example, if I decide to run a command, let's say I want to run a command wrongly. Let's say I want to say torche file, right? You see, file.txt. That command is wrong, right? So, you see, it says bash, touche, command not found, right? Bash. So this tells us that what is running on this server, right? The default shell in this server is bash, right? The default shell in this server is bash, okay? So this is what it tells us, okay? But let's say we want to bring in other shells into this place. You can see we can use the package manager, right? The package manager for this Red Hat server is yum, right? Remember, we've been using sudo yum install and sudo yum remove. So if for any reason we want to install any of the other shells that we've listed, right? We listed some shells here. Where are they? We listed some shells. Okay, we see we have just this and this. But if for some reason we want to install other shells, okay, we can go ahead and install them using the package manager, right? And the package manager for this is yum, okay? So if you want to install, let's say sudo yum install, right? So you can install multiple, multiple applications or packages at the same time, right? All you need to do is to specify them. So let's see, we said there's C shell, right? So there's C shell, then there's Z shell, and there's K shell, that's corn shell, KORN, okay? So we say there's C shell, let's see what happens if you want to install, right? You can use sudo yum install. If you want it to question us on, if we don't want it to question us, we can just put -y. With this, we are trying to install just C shell, but it is also possible for us to install multiple applications simultaneously. TCSH, right? Or multiple packages at the same time. Let's see ZSH, right? And let's see KSH, okay? So if we try to install all of this, you see, you can see it's installing. You see, KSH, TCSH, GSH, you can see installed, 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 okay? So if you remember, the other time, we went to cat this file, right? Sudo cat /etc/shells. So it means in directory called /etc, there's a file called shells, okay? Well, let's say I do not remember, right? I do not remember the name, the location of that file, right? I can just go ahead and say sudo find within root a file named, you see, I always want to use this because you find it really handy in the course of this program, right? And even in the course of your work, called shells, right? I'm looking for a file called shells, okay? That's the file name, okay? So you see, it tells me that this file is in /etc/shells. So without having to remember the long parts, like the absolute part, right? Just remembering the name of the file and remembering this command, you can always get the location. So what I can do is to cut that file, right? Remember initially, we only saw bash and sh, right? Let's see what we have now. You can see we now have bash and sh, right? And what else has been added to the file? Z shell has been added, CSH has been added, TCSH has been added, right? You can see CSH and TCSH. If you see the installation process, right, you see, it shows us what was installed, right? Installing KSH, TCSH, and ZSH, right? So what I noticed is that once you install the TCSH, it also comes with, right? You can see it comes with the CSH. And when you install the KSH, it comes with the RKSH. You can see. So CSH on its own, right, got installed because this was installed. Despite the fact that we stated it, it means it comes as a package, right? So other than the KSH, there's also RKSH. You can see. Now, what it means is that we now have all these different shells in our Linux server, right? Whereas the default shell is the bash, right? And if you remember, we said the bash is the default shell in newer versions, right? The default shell in newer versions, right? So that's the bash. So if there's an older version, it's going to be sh, okay? So now that we've established this, we've seen how we can also install other shells, right? You can see, we've also seen how we can install the other shells, okay? So now, apart from the approach we used to see what shell, right, is running, you see, by running this command, for example, it tells us, oh, bash, this command not found, right? That's what we see, okay? But if we want to ascertain the shell in use, okay, the default shell that's in use, okay, we can run some couple of commands, okay, can run some commands. If you run echo, right, echo is to display, right? If you remember, echo is to display, right? Echo to display, and you say dollar shell, right? This dollar shell is an environmental variable, right? It's a system. We'll talk about user-defined variable and system variable, right? So this any variable that you see that is in uppercase, that is stated in uppercase, is a system variable, right? Is a system variable. When you see a variable that is defined in uppercase, right? It is a system defined variable. But when you have it in lowercase, right, it is typically a user-defined variable, right? So we are getting ourselves introduced into variables, right? And once you understand variables, we'll see that shell scripting is going to be a piece of cake, okay? So now, look at this. Dollar, when you see dollar in front of a word or whatever, it means it is a variable, right? It is a variable that has been defined, but it's being called, okay? So it's defined and it's being called, okay? So echo dollar shell will tell us it tells us the default shell, you can see, which is bash, which we already found out by running a run command, remember? We ran the wrong command and we got this as bash, right? So you could also say echo $0. Okay, let's see. It says bash, echo $0, right? It says bash, right? So this is another way of ascertaining what it is. We'll get to see what $0 means as we proceed, okay? Also, there's a command you use for getting the process, right? Process, okay, tells us the process. You can see PS tells us the process that is running. You can see bash, right? Tells us the process. So that's one way, okay? Alternatively, you can say PS, right? Dash P flag, then $. Okay, we'll get to understand all of this. Then it brings the first line, right? But just running PS, right, tells us the process that is running, okay? But if you put dash P and you put this, it gives us the particular line, right? You see? So that is bash. You can see the different ways of ascertaining, okay? You can see this is one way, run a run command, and these are pretty straightforward way of explaining how to get it, right? So this is how we get our default shell that is running. Okay, now remember we talked about variables, right? We talked about the fact that there are user-defined variables and there are system-defined variables, okay? So when you have dollar, okay, in front of a word or whatever it is, okay, it is a variable, right? But when you have the variable all in uppercase, okay, that is a system defined variable, okay? And when you have it in lowercase, it's typically a user defined variable. Okay, from what we've seen so far, we've seen that a shell script is a file, right? Remember, this file, we're typing all sorts of commands in this particular file at a point, right? So we referred to it as shell script. And we also saw that that command will be executed in the order it has been presented, right? It will be executed in the order it has been presented, right? So it makes sense for us to specify those things in a logical order. Otherwise, we won't get the result we want to get, okay? Now, the extension for shell script is .sh, okay? So if you are writing a shell script, okay, you need to save it with the .sh extension, you know? You've been creating files, right? If you see our server here, let's see, ls, you can see we've created files, linux.txt, right? You see, Linux here is the file name, .txt here is the extension, right? So typically, a shell script should have a .sh extension. .sh, okay? Extension is used for shell scripts, okay? .sh. So usually for good practice, okay, a shell script, okay, let's just demonstrate that. Let's create a simple shell script, vi. Okay, remember our vi, we use this for, we use the vi to, as a text editor, right? Remember we said this is a file, okay? So we want to vi into a file. Let's call this file first.sh, right? First.sh, okay? So the first there is the file name. This is the first shell script we'll be working with, first.sh, okay? Or to make it simple for me, since I'll be doing this a lot, so let me just use number, right? First.sh, okay? So this is the first one. This is the first file that we are creating, okay? With VI, I want it to open a text editor, okay? And open it as this name. So instead of using touch, I'm using VI, okay? First, and the extension is .sh, okay? So I could do this, VI into this file, okay? So once I VI into this file has been created, okay? So to start, for good practice, to start a shell script, you should use shebang, okay? Shebang, which is hash, oh, I to insert, okay? Hash, right? Shebang, right? Hash bang, right? But it's usually called shebang, okay? Shebang slash bin slash bash. If you remember, when we're checking Echo Shell, right? Or if you look at, how do I put it now? If you look at when we ran when we opened the shells file, right? The shells file, it listed the different, what's it called that we have, right? The different shells, okay? So because I'm running on bash, okay? I could use shebang, okay? This is spelled this way. Let me just type it. Remember, when you indicate this in front of anything, it indicates comment, right? So this, right, this hash band, right, hash exclamation indicates, is pronounced, pronounced, okay, okay, that looks correct, as shebang, okay. This hash exclamation is pronounced as shebang, okay. So when you say this, you say shebang slash bin slash bash, okay. So instead of using shebang slash bin slash bash, okay, depending on the shell you want to work with, you can also specify shebang slash bin slash sh, right? Or shebang slash bin slash whatever shell you want to run, right? So this is just by the way, right? Shebang slash bin slash bash, okay? It should always start all shell scripts. Although it is not mandatory, okay? It is not mandatory, okay? Whether you have it or not, it is not mandatory, but it's good practice to show that what you have is a shell script, is an indication that, oh, this is a shell script. Because sometimes you can create a file, right, and not put the .sh extension, right? Does that mean that the script will not run? You see? So shebang slash bin slash bash. So for best practice, it means you should always include this, but it is not compulsory. Okay. So what it only means is that if this is not specified, okay, the default the default the default shell will be utilized to run the script. Okay. So the default shell will be utilized to run the script. So now, why do we need to even learn shell scripting? So let's just save this. We've not done anything. We just put the first line, okay? So if you see now, okay, you have if you check here, you see that we have a file called, where is it? First.sh, you see? We have this file now that has been created, okay? So now, why do we need to learn shell scripting? Okay, there are several reasons why we need to learn shell scripting, and included in those reasons will be, you want to automate tasks that you would ordinarily run manually, right? Like create like setting up a what's it called, a script to create a file, to create a directory, and to move a file into a directory. Okay, that is a simple shell script, right? Instead of having to type mkdir, type all of those, okay, you can just automate the task, right, by using a shell script, by running a script for everything to get done, okay? So you might have installations to do. Maybe you want to install a certain application, okay, a certain program, okay, on your server, right? Just as we've been using sudo yum install, sudo yum this, sudo yum that, okay? There are times you need to install a certain version or a specific version of a program, okay? So when you use sudo yum to install, what it's doing is that it's going to the yum repository and installing the most recent version that is in yum, right? Because yum is also being maintained, okay? There could be some newer versions because versions keep getting released every now and then, okay? Or there could be a situation where within your organization, okay, there's a newer version that is available, but they want a specific version, an older version, which is what is compatible with the application, okay? So you will need to install some scripts using you need to install some programs, okay? And instead of installing these programs manually, you can just write a script so that you can run these scripts on several machines so that the same application of that specific version can be installed. You can see that is one of the reasons why you we learn shell scripting, okay? We can also use shell scripts to take database backups, okay? When I say database backups, right, there are databases which could be relational databases and there's non-relational databases, okay? So relational databases are usually um, usually SQL based, okay, structured query language, SQL based, okay. So structured query language, which is a language used for writing to a relational database, okay, relational databases, okay, and non-relational databases, okay. So usually for relational databases, how you recognize them is on the name, okay. The names give them out, the names give them away, okay. For example, you can say my SQL, which is a relational database, a structured database. It's usually in a table form, okay? It's usually in table form, right? That's relational database, okay? Or structured database, okay? My SQL, PostgreSQL, okay? So these are some examples of relational databases, okay? There's also MS Server, Oracle, DB2, right? Okay. Other than this, there are also non-relational database, okay, which can also be referred to as NoSQL database, non-relational database. Okay. Examples of this will include MongoDB, Cassandra, and some other non-relational databases. Okay. So what are databases? Databases are used for storing, right? Storing databases, okay? For storing data, okay? So we can also use shell scripting for taking database backups, okay? Database backups. Okay, we can also use it for monitoring server resources, okay? If you remember, during our shell scripting session, we looked at some particular 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 commands, right? DF, DU, to see utilization of resources of the server, right? So you can also use shell scripting to to monitor server resources, okay? By putting together some of these commands, okay, in a script, you can monitor data, monitor server resources, okay? You can also use it for installing softwares on servers, okay? So let's see how that works, okay? So if, for example, let's see, we'll soon get to this point, okay? GitHub, package installation scripts. So there are some package installation scripts that I've written here. These are some of the topics we'll cover in the course of the program, okay? But to make it easy, right, I've set up some package installation scripts. You can see this shebang slash bin slash sh, right? So this is a script that has been set up, okay? So this script will install a Tomcat server, okay? This will install a Tomcat application into a server, okay? So you can see, don't be overwhelmed by all this you see, okay? Most of them is just for show, okay? Like this, put echo. It is advisable you do this, right? Remember how echo works, okay? To display, okay? I want something to display. That's why I have all of this. You can see. That's why it's looking like this. You can see echo this, echo that, echo this. So these are a few commands that we just need to understand how it works, okay? But this echo, it really doesn't make any difference, right? You can see these are some installation scripts, right? So installation scripts is just a combination of commands, right? Right? Put together in a script. And these scripts can help us to install, when there's a script, I can just process the installation and everything gets done, right? Without my interaction. I can run a script and just walk away, right? By the time I'm back, everything is all done, okay? So you can use shell scripts, okay, for installing applications, right? Installing softwares on servers. You can also use them for deploying applications or cleaning up contents of a certain directory, right? You can run some commands, put them in a file, okay, and set them up to clean up a directory, right? Maybe like the temp directory, /tmp directory. Remember, we talked about the /tmp directory being the directory for storing temporary data, temporary files, right? That's the TMP directory. Okay, now that we've seen all of this, okay, so what do you think will be the requirements, right? Prerequisites for shell scripting, okay? Shell scripting, okay? So number one requirement is the knowledge of Linux servers, okay, which we are familiar with already. We've been able to set up Linux servers, right, using using the distribution of our choice and using the AWS instance, right? We've been able to set up Linux servers, okay? That is a prerequisite, okay? Another prerequisite is the knowledge of Linux commands, okay? For the past 3 weeks, we've been looking at Linux commands. We've seen a couple of them, okay? So although that's not all, there are several other commands that we didn't look at, but we looked at some commonly used commands, okay? And those other commands that we do not know, right? As time goes on in the course of the program, we'll be running into commands. And as we are using them, I'll also be explaining the commands, okay? So that is that, right? So if you look at this now, if you look at this, we have created a file, right? A file, okay? We've created a file, okay? So now that's our understanding of the server. And the next understanding is going to be knowledge of Linux commands, okay? Knowledge of Linux commands. And lastly, some basic knowledge of programming, right? Which we are going to learn as part of this program. So, okay, what do we need to know to support our knowledge, right, of this, okay? We'll provide it. That's the whole essence of this program, okay? So once we have all of this, I believe we are good to go, okay? So now, what we need to look at is the steps for running shell scripts. Steps for running shell scripts. So we want to look at the steps for running shell scripts, okay? The first step is to create a file. You see, here we created the file and we called it first.sh, okay? So steps for running the shell scripts, okay? For first.sh, right? So let's see. Let's just take some notes here. Steps, okay, for running shell scripts. Shell scripts, right? Steps for running shell scripts. Create a file, okay, which we've done. Created a file, okay. The next step is to enter some commands, okay, and enter some commands, right? can enter some commands. Okay, and enter some commands, right? Then after entering the commands, we can now run the scripts. Okay, can now run the scripts. Okay, we can now run the scripts. So these are the steps for running a shell script. Okay, so now there are different ways we can run a shell script. Okay, there are different ways you can run a shell script. Okay, so to run a shell script, you can either say, let's say, you can put dots. You know what? Let's go ahead and create something. Okay, let's create a script. First.sh. Okay, where's my git bash? Okay, so let's go back to that file, vi into first.sh. Okay, so let's come down here. Okay, just want to run a simple shell script. I to insert. Okay, just want to run a simple shell script. Okay, so we can say echo, right? Hello, everyone. Welcome to become a tech pro.com. Okay, so this is just a simple shell script. Okay, I can say date, right? Remember, this date is a command, right? Can remember, I want to, maybe before this, I want to put who am I? The who am I is also a command. Who am I, right? Remember, who am I? Okay, is also a command. Okay, who am I? Specify date. Okay, so this is a simple shell script. Okay, because remember, when we're looking at echo, I said we can decide to state echo without this. Okay, you can decide to state echo without this, or you can decide to put it in quotation, right? You can decide to put it in quotation. But without the quotation, okay, this is, okay, causing some issues. The sign that we have there, okay, is causing some issues, okay? So if I put it in quotation, right, you can see, and that's the good thing about shell scripting, you get to know when you are getting it right and when you are getting it wrong, okay? So hello, everyone. Welcome to becomeatechpro.com, right? Who am I? This will return the name of the person that is communicating this and put in a date, right? Put in a date, okay? So now, when you look at this, okay, if I run this is just there, okay? And this is not going to apply, okay? Because this is a comment, right? In shell scripting, when you have this, it indicates comments, right? This is a single line comment, okay? This is a single line comment. So if you look at this, for example, right? This is a script. We can save this script now. Escape, column, press escape, column, escape, column, WQ, okay? So I'm saving the file. So this file has now been saved, okay? We've created the file, okay? Let's look at the steps. We've created the file, enter some commands in the file, right? And we've gone ahead. We now want to go ahead and run the script, okay? So now if you look at this, okay, there are different ways we can run a script. Okay, so if, for example, you can decide to say dot slash, right, and specify the file name. File name dot txt. You can do this dot sh, I mean, because this is a script. Okay, file name dot sh. Okay, another way of running it is to say, oh, I want to use sh to run it. Okay, file name dot sh, right? Or I can say bash file name dot sh, right? Okay, so these are different ways I can run the scripts. However, to be able to run the script using the one at the top here, okay, which even looks not so clear, okay, to be able to run the script using this approach, like dot slash, right, then specify the file name, an executable permission needs to be added to the file, okay? So the file needs to be an executable file, okay? So if you remember, going back to our git bash, okay? If you remember, if you run ls-ltr, for example, you see, this file has a 644 permission. For this to be executable, we need to make it a file with the XXX permission. Okay, we need to be able to add the XXX permission, right? You need to be able to add the XXX permission. Okay, so without the XXX permission, we'll not be able to use this first approach of saying dot c slash, what's the file name? First dot sh, right? This is the name of the file. You see, if I try to run it now, you can see it says permission denied. Okay, so it means I need to run it with the executable permission. Okay, so what even happens if I decide to add sudo? Okay, if I decide to add sudo, you see, it says command not found. But permission denied, you know, when you see permission denied, what comes to your mind is, oh, let's use sudo, right? But this time around, it's saying command not found. The reason why this permission is denied is because in the first place, this file is not an executable file. It doesn't have executable permission. Okay. So if we want executable permission, we can show mode, right? What's the file name? You can say Ugo plus X, right? X is executable permission, okay? Or we can just go ahead and say, want to give it 777 permission, okay? So Ugo plus X, show mode, Ugo plus X, what's the file name? First dot sh, right? You can see, if you go ahead and do your ls-ltr again, okay, you see that this file has now changed color. It's no longer looking like a regular file, okay? It is now an executable file, okay? So if I go ahead and run this command again, okay, this command, dot slash first dot sh, you see, it says, it returns something. Hello, everyone. Welcome to become a techpro.com. User, EC2, you see, dash user, signed on this date, you can see, and this time, you can see, 1:54 p.m. Okay, no, 5:01 p.m. Okay, sorry. So that is this, you see, this is one way of running a shell script, okay? But you won't always want to go and be changing permission to a file, right? Which doesn't make sense, right? Like changing file to executable just because you want to run it like this. When there are simpler ways of running a script, right? So you can just specify sh, right, before this, and you run your scripts. Or you specify bash, because we have bash as well, and you run your script, okay? So let's see something. Let's see something, okay? So if we decide to go ahead, let's see. Let's remove that executable permission, okay? To remove it, you can just say ugo minus x, okay? To take out the executable permission, right? Okay, so now we've changed mode. If we do our ls-ltr now, you can see it is now back to what it was, right? It's no longer the executable file that is showing green again, right? You can see it is now a regular file. So instead of using this approach, okay, we can decide to just say sh space first.sh, right? So if you run this sh first.sh, right? What it will do is that it's going to run the script using the specified shell, right? You see, sh. Okay, we want it to run it using sh. Okay, so let's run. You can see, did it run it? Hello, everyone. Welcome to becomeatechpro.com. We can also go ahead and use bash, right? Instead of sh, right? We can go ahead and use bash, right? Use bash, you see, it runs it. Let's see, what else do we have? We have C shell, see, it runs it. We have T shell, right? You can see, it ran it, okay? What else we have? We have Z shell, right? We have Z shell, it ran it, right? We have what else? Con shell, K shell, it ran it. We also have RK shell, you can see, RK shell, it ran it. So let's see what happens. If we decide to remove some of those shells, if we decide to remove some of those shells, let's say we are taking out, let's take out TCH, okay? There's sudo, remember, yum remove, okay? You can use this remove to uninstall. Sudo yum remove, okay? TCSH, okay? -y. You see, I've removed it. I removed T shell, you can see. So if we go back to that our file, right? That our file, our shells file, okay? And or say cat, let's cat that file. We know it's in /etc, and the file name is shells. Shells, okay? So if you look at this, what has happened? All we took out was T shell, right? But TCS, we took out CCSH, right? We also noticed that C shell is gone, right? C shell is gone because they are together, right? They are together, always together, right? So you can see we uninstalled the TCSH and C shell is also gone. So if we go ahead and uninstall maybe K shell, you also see that our K shell will be gone because they are together, right? Let's say we take out K shell, okay? You can see. You take that out, if you run your cat it shell, you see what happened? K shell is gone, RK shell is also gone, okay? So we are now left with bash, sh, and zsh, okay? So if for some reason we try to use K shell, you see, we don't have K shell again to run. You can see, what does it say? says there's no such file our directory, right? Because we've uninstalled that shell, okay? You can see we have different shells and we've seen different ways of running the shells, okay? So now that we can also run our scripts in debug mode, okay? We can also run our scripts in debug mode, okay? So when you run your script in debug mode, what it does is that it will run the specific lines, right? And it will show the content of the script returning those commands, okay? So for example, let's say we want to use bash. Let's clear this first. Clear, okay? Let's say we want to use bash, right? Bash first.sh, we know this, right? We know how to run script this way, okay? First.sh, we are trying to run this, okay? So to run this in debug mode, all we need to do is to introduce a -x flag, okay? -x flag, okay? We introduce the -x flag. Ordinarily, this alone, we run our scripts, okay? But if we decide to run it this way, you see, we are running it in debug mode. Debug, D-E-B-U-G, debug mode, okay? So that way, it's showing us what is the command that is giving what. This command, this is what it's doing. This who am I, this is what it's doing. This is what it's doing. So running in debug mode will also help us to understand scripts, okay? You can pick up a complex script online, right? And try to understand what the script is going to do, okay? Okay, so that way, when you run the script, you see, okay, this is the command that gives this. You see, who am I give us this because I'm running as EC2-user, okay? Date is giving me this. You can see the current time, 5:09. And the reason why this time is correct is because we set it up in the previous session, right? We set it up as using the time date CTL command, right? Time date CTL command was what we used to set it up, okay? So now that we've established this, the next thing we want to do is to say, okay, now we know that with this, we can run in debug mode, okay? And to run in debug mode, all we need to do is to introduce the -x flag, right? Once you introduce the -x flag, you run in debug mode, okay? So, for example, if you want just specific lines, okay? Now, this way, you see that we have everything here being run in debug mode, right? But if for some reason you want specific lines, okay, to run in debug mode, not all lines, right? Just one specific lines to run in debug mode, okay? So we can go back to our scripts and do something. VI, let's just VI to first.sh, first.sh, okay? So you can come here, for example, okay? You can, for specific lines alone to run in debug mode, okay? I to insert, okay? Let's say I want just who am I to run in debug mode, okay? So you can just say set, right? -x, and come under here and set -+x. Okay, so I've enclosed just who am I here within set-x and set+x. Okay, so if I come here and save this, escape, column, WQ, okay, if I decide to run this now, okay, you can see who am I, okay, you can see the first line, you see the first line did not run in debug mode. okay, only this is running in debug mode. You can see, okay, you can see only this is running in debug mode. And also, for example, you can see the last one did not run in debug mode. But what happens if we decide to go back to that file, okay, and take this out, okay, I to insert, let's take this out, okay, and we decide to do this, okay. So if we decide to do this and run this, you can see everything under, you see, let's go back to the file, see, you see, what we have here is that the first line did not run in debug mode, okay. The second line is running in debug mode. Even the third line for date is also running in debug mode. So what you notice is that if you look at this file, set -x, anything under will run in debug mode, okay? But if you don't want everything under to run in debug mode, you need to come here and set +x. So that way, it's like closing, right? You can see, it's like closing. So you just want this alone to run in debug mode, not everything, right? So, Q, okay? So if I run bash first.sh, you see, only this, right? Who am I? You can see this set +x is just indicating the closing, right? Okay, so you see, it doesn't affect this. We don't see +date that we saw here, right? You see? So this is how we run in debug mode, okay? So that is how to run in debug mode. Now, let's take a look at something also very interesting, okay? Let's look at a file naming convention, okay? So if you look at this, we've named our file, right? We called our file first.sh, right? So some file naming conventions. Right, file naming conventions. Okay. So you can have a file with a maximum of 255 characters, of 255 characters, right? 255 characters, which could be made up of alphabets, okay? Made up of alphabets, made up, okay? Composition could be alphabets, right? Numbers, okay? Dots, okay? You can put dots in between, okay? You can put underscore, okay? You can put underscore, right? But you are not supposed to put space in between. Once you put space in between your character, it takes it as a different file, right? For example, if you say mkdir, let's take a look at something. Let's take a look at this, for example. Let's say we touch, okay, 1, 2, okay? Let's say we touch 1, 2, you see, we put a space in between, touch 1, 2, right? So it's either you have them like this, okay? Once you have 1, 2, it means you want it to create two files. So if you check ls, right, -ltr, you can see 1, 2 got created. Two different files, okay? But our intention was just to create one file called 1, 2. But because we put a space in between, okay, You see, two files have been created. So convention, do not put space in between your files. Okay. So if you've been using Windows and you put space, you see, it works with Windows. Okay. Because you are using the GUI, you can put space, you can do all of those things, right? But with this, you don't put space. That's why you see all the files and directories we have, we've been using underscore, if you want it to be clearer, use uppercase somewhere, lowercase, you can just use any of those 255 characters, right? Any word, any letter, any number, any underscore, you can have it multiple times. Look at this, class underscore 101 underscore backup, right? So this is a typical example, okay? So now that we've established that, we should also know that Linux or reserved words cannot be used, okay? Linux commands or reserved words cannot be used, okay? Okay, so let's see. Let's say we want to create touch, right? Touch. You see, it actually creates it. Okay, if I go ahead and check ls-ltr, it's not that it won't create it, but it's not a good practice. Okay, it's not a good practice to use Linux commands or reserve words. Okay, you can see touch, it created it, right? But it's not a good practice, right? To do that, to use Linux commands or Linux words. Avoid Linux commands. Okay, avoid Linux commands. Linux commands. Linux commands or reserve words. Okay, so that's another point. Then we should always remember that Linux is case sensitive. Okay, Lagwaja, for example, is not the same as Lagwaja. Okay, Lagwaja is not the same as Lagwaja. So take note of case sensitivity. Okay, take note of case sensitivity. Okay, Lagwaja is not the same as Lagwaja, right? So you can see. So always take note of case sensitivity, okay, when creating a name, okay? So create a name that you can remember how you've written it and all of that, okay? So now we've done this, okay? So if you go back to our script, okay, I want us to go back to that script, our first.txt, okay? Our first.txt. Let's go back to first.txt. Or alternatively, we can just look at a different script, okay? Can look at a different script. Let's create a different script now, okay? Let's say we are done with first. Let's create a second.txt, okay? Let's VI into second.txt, but before then, instead of using VI, let's try to do something with length, okay? Want to copy first.txt, for example, first.txt, first.sh, sorry, and we want to copy it into second.sh, okay? So you want to copy first.sh into second.sh, okay? So that when we open second.sh, okay, when we open second.sh, we have some content so we don't start typing all over, right? We just copied first into second, right? So we can have a second.sh file, okay? So we can now come here, let's come here and try to delete some things, okay? Or instead of even deleting, let us say, if you remember, we already know that this one here, I to insert, okay? When I'm in insert mode, I can make modifications. Otherwise, I'll not be able to make modifications, okay? So this is the script, right? That's our second.sh, okay? If you remember, this, okay, is a comment, right? If we remove this, okay, and we say echo, okay, we say echo, and we do this, okay? If we do this, we'll see that this line will show up, okay? This line will show up. But if we decide to come here, okay, as we've demonstrated before, we've demonstrated a single line comment, okay, and we come up here, we can come here, put hash, okay, and still put this here, okay. So you can see this is a comment. This one, this part is a comment, okay. So we can say, let's come here and put something like this, okay. This first one is a comment, whereas this is not a comment, okay. You can just put a note. Note that this is not the comment line, okay? So this way we'll know the difference, right, in what gets displayed, okay? This is not the comment line. So now, looking at this, you will see that this first part, let me try to separate them, okay? This first part is a comment, right? Because the hash precedes it, right? Whereas this other one is expected to run as part of our code. You can see hash is pronounced as she's banned. Note that this is not the comment line, okay? You see, I want this to display as part of our code, okay? So if I now go ahead and scroll down, you see, I have some other commands at the bottom, okay? All of these commands which showed up earlier for us. For example, if I do not want this command showing up, okay, I can use a multi-line comment. I can either go down and use single line comment all through, which you must have seen in some files, right? When we were checking the SSHD underscore config file. If you remember, when we're trying to set up some things, you saw that the script had something like this all through. You see, it had something like this all through on different lines, okay? So this is the use of single line comments, okay? Can use single line comments across the different lines, okay? You can use single line comments across the different lines, right? Like this. But if for some reason I want to use multi-line comments to affect all the 3 lines, okay? What I need to do is to type less than sign twice, okay? And put whatever, right? Anything you like, whatever, right? You can put whatever you like there. That's I'm putting whatever. Or you can say, just simply say, this, the enclosed comments. I think this will help. The enclosed comments represent, right, multi-line comments, okay? Can't be this, it doesn't have to be this long, okay? But I'm just trying to show us something, okay? So whatever you put up there, okay, you must be willing to put it down here. The enclosed, you can see, the enclosed comments, I'm just using this as explanation, okay? You could put whatever. You could put A, you could put A, but if you put A at the top, you must also put A at the bottom, okay? The enclosed comments represent even the spacing, you see, if I mistakenly type represent, right, I must be consistent, right? So I should come here and type exact same thing, represents multi dash line comments, okay? Okay, so you see, whatever I type up there, I must also type it down here, okay? But we need to take one more step, like doing something here, okay? So let's see. I think I should just close this up, okay? Because it's giving me some vibes that I'm not, you can see the coloring is different, okay? So usually when you do this, you see, just want to be able to show what I've typed, okay? Represents the enclosed comments, see, comments, the enclosed comments. Let me cover up everything, okay? You can see, it's giving me the vibes now, okay? Because it's seeing the other ones as if it's separate, okay? So usually you want to copy, right? Once you highlight, you've copied already, okay? Then you go down. Let me, instead of typing this all over and correcting, to minimize mistakes, okay? You can just do this. So what it means is that whatever it is you've put after these two less than signs, you must repeat exact same thing down here. You can see. Now the color is giving me the right vibe, showing that it will work, okay? So if you put a space, if you put spaces in between, it won't function well, okay? So now that we've established this, when we run the script, what it means is that everything that is in between here, all this echo, whatever, whatever, right? That we're able to see when we run the initial command, we won't see them. The only thing that I expect to display is this, what we have up here. Echo, right? This is all I expect to see, okay? This line, okay? Every other thing within this line, okay, will not show up. So instead of using something this long, we could just say less than, you can just say A or B or whatever. But if you put A there, you must put A at the bottom here too, okay? So you have to be consistent. But if for some reason, in the course of typing, I made a mistake, right? Let's say I made a mistake in the course of typing. I want you to see something, right? If in the course of typing, instead of putting comments here, I decided to put comments here. You can see it's showing that there's a problem because it won't work, right? If I run the script, it won't work. This line is going to give me like an error, right? So let's see. Let's run this correctly first, okay? Or let's run it wrongly and see what we'll get. WQ, okay? Want to run it wrongly, okay? So let's SH second, need to type it as it is, second.sh, okay? Can see. What is it saying? It's saying shebang is pronounced as shebang, right? Note that this is not the comment line. Remember that thing we put there? Just for us to know that there's a difference, right? Second.sh, line 11, warning, here, dash document at line 7, delimited by end of file. Wanted, you see, is saying, oh, this is what is expecting. Can see, wanted, the enclosed comments represent multi-line comments. This is what is expecting. That line 7 is delimited by the end of file. Is expecting the enclosed comments represent multi-line comments, right? You see it? Whereas, what do we have in there? Multi-line comments, right? Without the S. So it's telling us what is expected. You can see how nice, right? So usually, when we get it wrong in Linux, in DevOps or whatever, okay, some of the tools we are using will also provide suggestions to guide us, right? Some suggestions to guide us. Oh, command not found. Okay. Even using some distributions, maybe Ubuntu, it will even make recommendation for certain commands to be used. Okay. But because we want to learn, right? So we are looking at using Red Hat, right? So that once we start experiencing those, it will be all easy for us, right? We'll still get to use another kind of distribution. We'll use Ubuntu in the course of this program as well. Okay, so you can see now, if I run this, you will see what we'll get. Okay, you see that all of this won't show up. It's only this line that will show up, right? But everything, multi-line comments, right, won't show up. Okay, so let's just enter. Okay, so let's run the command again. sh, or we use bash. Okay, second.sh. Okay, so you can see nothing else is showing up. Okay, just this line. See, this is how we work with multi-line comments. Okay, so the only one that is showing up now is the one that is not commented. Okay, the one that is not a comment. Okay, so now that we've seen this, okay, we should also note something. Okay, let me go and update that script. Okay, let me go and update the script. Okay, so in in Java, okay, anyway, it's not something we are looking at, but in Groovy scripts, okay, anyway, when we get there, we'll figure it out. So different programming languages have different ways of representing comments, okay? So this one is strictly for, what's it called? It's for bash shell scripting, okay? Shell scripting, right? But when we start to look at Groovy, which is something we'll do, okay? And when we start to look at XML, okay, which is something we'll also do, by then I will also introduce to us how we use the single line comments and multi-line comments, okay? So this way, we know we are working with shell script, and let's know that, okay, a single line comment, which is represented by hash, which is preceded by hash, and there's multi-line comments, which can be enclosed by less than, whatever, and whatever. You get? So now these are single line comments and multi-line comments. Okay. So when we get to uh, when we get to other languages, okay, we'll just mention it in passing, and by then we would have known so much by then. So it's just going to be a piece of cake because we'd have been seeing all of these things. Okay. So now that we've established this, let's see what we can do. Okay. So let's escape. Okay. Escape, colon, Q, right? Didn't do anything on the file. Okay. Now, the next thing I want to do is that I want us to look at variables. We've looked at single line comments. We've also looked at multi-line comments, okay? So the next thing we want to look at is variables, okay? We want to look at variables. Okay, in variables, okay, in the course of the class, we've mentioned that there are user-defined variables and there are also system-defined variables, okay? So now, what are variables, okay? Variables are like containers for storing values, okay? Variables are like containers for storing values, okay? So usually we can define any variable, okay? Variables, okay, let's just put some note there. Variables are containers. Containers for storing values, right? This is something we've always experienced, right? Variables are containers for storing values, okay? So we can look at steps, okay? Steps, okay, in using variables. Steps in using variables. First step will be to declare a variable, right? So declare a variable. That will be the first step, okay? So after declaring a variable, we assign a value to the variable. Value to the variable, okay? So we declare a variable and then we assign a value to the variable, okay? So now, in declaring a variable, you can declare any kind of variable. You can say x is a variable you've declared, okay? You can declare y as a variable. You can declare name as another variable, okay? So all of these that we have here are variables we've declared, right? Can just declare, let me just put this like this. Can declare variables, okay? Can declare variables. Let me not put anything so it doesn't look at it. It's part of it, okay? So you can declare any variable you like. You can declare x as a variable, y as a variable, or name as a variable. Even age is also a variable, right? Now, for each of these variables, you can assign values to them, okay? You can assign values to the different variables, okay? So first step is to assign variable, and next step will be to assign a value to the variable. For example, you can say x, for example, let's say x equals 10, right? So this is assignment of value to a variable, okay? X equals 10, okay? X equals 10, okay? So if you look at this, you notice something, right? That there's no space in between the variable, you see, this variable, the first one is variable. The second one is the assignment operator and the value. You can see, we didn't write it as that, okay? So in shell scripting, there should be no space, okay? There must be no space, okay? Otherwise, we'll have issues, okay? So these are just some key components that we just need to understand, right? As it relates to shell, okay? With other programming languages, maybe Python, you can use it with space and you can use it without space, okay? But with shell, okay, you must not put any space in between, right? In between this, you can see x equals 10, right? So you can see no space, okay? So we can also assign another variable and say y equals 20, you can see, right? This is another variable that you've assigned. Then you can say name equals, right? You can say name equals, put in quotes, Ademola, right? You can see name equals Ademola, okay? Now, you can see we've gone through step one, we declared the variable. We've gone through step two, we've assigned value to each of the variables, right? Then step three will be what? Step three will be to display variables, okay? To display the values of variables, you can say echo, right? What's the variable? The variable here, for example, is X. The variable here is Y, and the variable here is name, okay? So if you say echo dollar X, right? Echo dollar X, or you say echo, let's put it this way, okay? So the next step will be, let's say, the next step is to display the values of the variable of the variable, right? Display the values of the variable, okay? So to display the values of the variable, we want to use echo, right? Remember, echoed command. Echo, okay? You can use echo, right? Echo $x, echo $y, and echo $name, okay? $name. You can see all of this will display the different variables that have been specified, okay? Echo $x, echo $y, and echo $name. So what you are doing is that you've declared a variable, you've assigned values to the variable, and you've now displayed the values of the variables, okay? So with this knowledge, we can now go ahead and run a third script and call this third.sh. But this time around, we want to use variables, okay? But before we even go ahead and run the script, okay, let's talk about the system-defined variables and the user-defined variables. So if you look at this that I've defined, you can see this variable that I declared here, right? These are user-defined variables because I'm the one that set this variable. I decided what it should be, right? I can decide to change this from name to nomenclature or num, right? I can decide to say this is num, okay? But once I change this, I need to specify num here, right? Nomenclature, right? So whatever it is, right, I can define, okay? So I can define my variable, but when you are defining a variable, you should always ensure that when calling the variable, you specify the right name. If you define this as name, and you go ahead and call it as name, okay, you can see name is not the same as name because Linux is case sensitive. It won't see it. It won't just see it, right? Because Linux is case sensitive. So you need to define it as it is. Okay? You need to define it as it is. So what we are going to do now is that we are going to do something, okay? What we are going to do is that we are going to okay, write a script, okay? But before then, let's take a look at system-defined variables, okay? You can see system-defined variables are usually in uppercase, right? They are usually in uppercase, okay? So for us to be able to see, let's say this is our, let's clear, okay? So if you type env command, you see, env command, okay, has displayed several, let's minimize so we can see clearly, okay? You can see env command, okay, has displayed several system-defined variables, okay? exv, you can see, when you say shell is defined as being /bash, /bin/bash. Remember the other time when we wanted to identify the default shell, right? The default shell in use. We used $, $shell, right? You can see this history size, okay? If you type a command, right? There's a command called history. Let's type history. Okay, so it's telling me that so far, these are all the commands we've run. Okay, you can see history, clear, PWD. You see, this is history of all the commands we've run from beginning. You can see when we're creating directories. This one that we said will fail. You see, these are the commands you see, when you run the history command, it gives you all the commands you've run. You can see all the commands we've run. vsudo, when we said it's advisable to use vsudo instead of just going straight to the sudo file, right? You see, these are all the commands we've run so far, right? And see, we have 220 lines. You can see the last command we ran, env, then we ran history, right? You can see, clear, okay? You can see all the commands. So if you check the env command again, it tells us that history, right? You can see, says, where is it? Okay, shell, you can see it tells us default shell, what it is. Okay, its size, history size is 1000. So what it means is that those 220 commands that you saw, by the time we cross 1000, it will only be displaying 1000 commands. Okay, so most recent 1000 is what is going to always display. You can see host name, you can see this is my host name, this is what is defined. $pwd, you can also do $pwd to give you the home, right? Dollar, you see, you can see $home, you can run $home, you can see language, ls colors, you can see. These are all system defined variables, right? Temp, right? You can see Linus role requested. User, I can say $user, right? Instead of saying using who am I can use $user. You see, you can see these are, you can see this is a part. You can see mail, you see, these are different environmental system defined variables, I mean, okay? So if for some reason you want to change the default value, okay? Maybe from the east size, for example, okay? You want to change it from what it is, okay? You want to change it from what it is, right? To maybe 200, for example, okay? You can change it. You can change that as well, okay? Something you can do, okay? All you need to do is to use the export, right? Then specify the variable, okay? The variable that we saw there was its size. Let's say we want it to display just 100, right? And not the default 1000, right? 100, just want 100, or we just want it to display 20, for example. Just the last 20 commands, right? So you can do this, right? You run this export command and define your new its size, okay? So if you do this, okay, and you go back to check your history, for example, let's see our history. See, history. See, it only gave us the 20 commands, right? Last 20 commands, okay? But this is temporary, okay? So to make it permanent, you need to copy this file and go to a file, right? Copy this command, right? Export its size 20, okay? Copy this command and go to a file called the bash underscore profile file, okay? The bash underscore profile file is right here, right? But you won't see it except you use ls-a. You can see, when you run ls-a, you see .bash underscore profile file, okay? .bash underscore profile file. So to get into this .bash underscore profile file, to make that thing permanent, you need to go into .bash underscore profile file and enter that, okay? You need to go there to vi to .bash, because it's right here. I don't need to use the absolute part. Bash underscore profile file, okay? You come here, okay, and come to the bottom, okay, to add that variable. Okay, you can insert to now define that variable, right? You can now copy and say export, right? If you want to make it permanent, say ist size, right? Ist size, its size, you now say equals 20, okay? So because the one we did earlier, if once we restart our computer, right? Once we restart our computer, we just realize that, oh, it has been reset back to 1000. But if you want to make it permanent, you come to this file and go to the bottom here and apply and save it, okay? Once you save this, WQ, you see, you now need to run a source command, okay? Source command, okay? There's a source command to refresh the configuration, okay? The name of the file is .bash underscore profile, okay? .bash underscore profile, okay? So once you run this, okay, it's going to be permanent, okay? Because it is already in that file, okay? You can always take it out of the file, just as we've brought it in, you can always go ahead and take it out. So if you restart the system and we check history, okay? For example, you can see the way it is now, okay? So if for some reason we decide to log out, let's exit from the server, okay? You can see we've exited from the server. Let's try to come back in, okay? Let's come back in to the server. Let's just copy this, okay? We already know how to SSH. We understand the command, okay? Since AWS has given us this on the platter of gold, let's use it, okay? So if I run history, for example, you see, it still shows me the last 20, right? You see, it shows me the last 20, right? But if for some reason I want to come back to this file, I can decide to go back here, for example, and take this out, okay? Taking it out, escape, column WQ, okay? Saved it. Let's run the source command, okay? If you run history again, you can see it shows us few commands because everything has been cleared off the history, okay? But if we decide to count this, okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But okay, I think this just requires some time, okay? You can see, let's source it again, okay? We run it again, see? Anyway, before the end of the class, we'll try to run that command again and see what it displays, okay? Because we should be having more than 20 because we've taken that item out of the file, right? See, it's no longer in the file, okay? So it should be displaying the right number. Okay. So now remember, we use env to see all the environmental variables, right? So if you come here, okay, this is another way of looking at it. Okay, its size is set at 20. Okay, so we can decide to go back and set the east size at 100. Okay, we can set the east size back at 1000. Then once we refresh it, we can now go back and delete. Okay, to insert, you can say there's export, right? East size, you see, size equals 1000, right? Can save this, WQ, see? Now run the source command, see, source. So if you check history, it's showing this, okay? So if we go back and exit, okay, and we run that to go back in again, okay? So we are back in, let's check history. You can see, showing 21 now, you can see. It's now showing 21, right? It's no longer showing 20 because we've set the history back at 1000, okay? So if we go back to the file, right, and decide to remove this, right? Decide to remove this from the file, okay? So this is just by the way, because we'll be using this file. That's why I'm displaying, I'm trying to show you how this file works, okay? Can use it to set environmental variables, okay? You see, we set it back at this, okay? So if you run the source command, source, let's run the source command, okay? And check history now, history, you can see it's now counting to, it's going to count to 1000, okay? So now, apart from the env command, you can also use the print env command, okay? Print env, okay? You can use env or print env, but I'll prefer to use env because it's shorter, right? So you can see either print env or env will give us the same list of the different environmental variables. Okay. Now, with this, I want us to come to bring this class to an end. So in the next session, we are going to run a script using variables, right? Then we'll continue that way. So are there questions so far?
Yes.
Okay, great.
Is shell Python the same? Because I think as I heard when you mentioned about Python, you can
Okay.
create space, right?
Yeah.
But not in shell. So if shell is an interface, is it the same thing? Is Python an interface too?
Okay. You see, shell
Right.
is not necessarily an interface. Is an interface, right?
Okay.
But shell scripting is like a programming language.
Okay.
Okay. So just as you have shell scripting, you also have Python as a programming language.
Okay.
You have Java as a programming language. There are
Right.
several programming languages that I'm whispering this. There are some I've never even heard of. Okay, so let's just look at this programming languages list. So there are just some that are very popular languages list, you see. Let's see this. So let's go to Wikipedia, wiki, you see. Because of this program, you want to use there are some things, see. All these are programming languages, see. You can see,
Right.
you can see. Is it possible to know all of this? Even programmers only know one language, right? But the popular amongst them, right, are the likes of Python. You can see Java will be here. See Java. There's JavaScript. There are some that I don't even know, right? That I've never even heard. You can see these are all programming languages. But the way it is that, okay, let's look for under P. Let's look for Python, PY. You can see Python is here. You see, when the other time we're talking about databases, we talked about SQL, structured query language, right? You see, these are different languages, Scala, right? Scratch. You know, my children play with this Scratch. It's a game. They use it for doing all sorts. They say, I'm playing Scratch, I'm playing Scratch. You see? So these are different programming languages. You see? You can see Z shell. You can see. Let's see. Let's go up. Right? You can see. You can see Bash. You can see. You can see. So these are different programming languages. Okay. So in a way, we can also say, we can also look at them and consider them as interface because depending on the language, right? Depending on how you present the language, right? And the platform you are working on, right? But shell, you are looking at operating systems. Okay, that's the way to understand it. All right. But there are different languages and different people will understand different languages, right? If you speak Yoruba, I will understand. But if you speak a different language, I might not understand. If you speak Spanish, I will not understand, right? Because my head is not configured for it, right? So one way or the other, we can, we can also look at it and see it as an interface. But when we are looking at it as an interface, you are looking at the platform, okay, that they are working, that they are compatible with, right? Because all of these languages, there are different platforms that they are compatible with, you know. So, um, so in that situation, we can say, oh, interface, right? This language can only be understood when you work on certain plugins that have been installed on VS Code, right? Like when you look at this, my VS Code, right? This one that I'm working with, see, this one is in YAML, right? .yaml, right? And all these colors and all of that, spacing, like putting two space and this before specifying what I want to specify, it's all about YAML syntax, okay? One needs to understand YAML to be able to see the way it is now. If I decide to, you can see it's already underlining it, showing that it's not following the syntax.
Okay.
You see? So that's that.
Okay. Secondly, it's so funny. Every time on every new class like this,
Yeah.
I get I get lost of catch up.
Okay. When
Like
when the class starts, right?
yeah, yeah, like you know, it has to do with my I just got out from work.
Yeah, I
I'm
get it.
so tired, but I gotta be in class. Let
Mm,
me say it like I just have time to study
yeah.
after like Monday through Friday, I go to serious studies. You
Yeah.
understand? I have
Mm-hmm.
questions. When is there? What time is there? This time I text and say, okay, right. Sometimes I want to talk to you for more clarification
You can
than
you can call me
chatting or
anytime.
leaving a message.
You can call me anytime.
Okay,
I'm very open. I'm very available.
okay,
Just call me at any time. If I miss your
okay,
calls
perfect.
and I'm not available, I'll
Call me
gladly
back.
call back. Even people that are not enrolled in the program, they are calling me and I'm responding to them. So,
Okay,
so if I miss your call,
all right. That's
just give me a little while.
yeah.
I'll call back.
Okay. because every lecture is just like a magic to me. But I know,
How are you?
everything about studies is got time to study, right? Yeah, so
Yeah,
that's what I'm doing to catch up.
yeah,
Yeah, well, very much okay.
yeah. That's okay. You can call me, reach out to me, and if I miss
Okay,
your calls, I'll definitely respond, and we'll walk
okay,
through it together
right.
because
Okay,
that's the whole
thank you.
essence of the program.
Yes,
Understanding it, getting prepared. It's not going to be easy, right? I'll say that because this is a new
oh,
field,
yeah,
right? This is a new field, but at the end of the day, depending on what we put in together, right, that will determine the output, right? Because
right.
if it's very easy, everybody should be claiming DevOps engineer, right?
Yes, yes,
But it's because of the difficulty, right, and the challenges that brings out the best in you, right?
right,
And I believe we are the winning team, so
right.
everything will work.
Yeah, even
So
in
anytime, yeah,
the training I attended today, they were encouraging people like my coworkers. They say, don't focus on this job alone.
hmm,
Divert into technologies. A lot of things happening in the technological world.
yeah,
And when I heard that, I just hit myself, say, okay, I guess I'm in the right direction.
yes, you are. You can
Yeah.
never get it wrong.
Yeah. Okay. Thank you very much. And I'll see you tomorrow. Okay.
You're welcome. Yeah,
Have a good night.
you too.